Okay, welcome everyone. I have a sore throat, so you might have a hard time hearing me without amplification. So perhaps I can just dance my talk. Okay, welcome. I just come to you and I don't know. We'll make it work somehow. So I'm really happy that two of my pet projects made it into the keynote of EMEA. You saw APOC and you also saw the Spark connector. So that makes me really happy. And today we have 3 lightning talks actually on APOC. And in general, I think user-defined procedures were the best feature in 3.0, in Neo4j 3.0, because it enables you to extend Neo4j with your own custom functionality. So whatever currently Cypher does not provide, but you need it, you can just add it really quickly and have it available. And not just available as a standalone call that you can just call procedure, but you can embed it into your Cypher call. So you can have a complex graph operation, find stuff in the graph, and then there's just this one thing that you want to do, like for instance, running a graph algorithm or migrating something to a different model or something like that. And so the procedure allows you to do that while not leaving kind of the scope of Cypher, which is really, really cool. And so the next 3 lightning talks will actually cover different aspects of APOC. So I'll start with user-defined functions, a new feature in 3.0, which he actually forgot to mention, right? Anyway, it's the best feature anyway, so but. And then the next ones will be data integration with APOC and graph algorithms with APOC. So it's pretty cool stuff. User-defined functions. So if you remember procedures, it's a named piece of code that you can call from Cypher. It takes parameters, it returns a stream of values. So it can be used for anything from loading data from somewhere to running a custom implementation of an algorithm to running a custom implementation of some business functionality and so on. And in general, it's just implemented in any JVM language, for instance in Java, by writing a little piece of code, annotating it, and deploying it to the server. And then when the server starts up, these procedures are available in your instance, which makes it really easy to use. So this is an example of a really simple set of functions, procedures. One is creating a UUID, and the other one is formatting a date. And so I call one procedure which creates the UUID, I call the other procedure which formats the date, and then I create a document that has this creation date as a string and the UUID there. So, but if you look at that, it's actually quite cumbersome to use this way, especially if you have quick functions that just convert value, that just generate something, or that just operate on a collection or something like that. So you have to do the call, which is a clause, you have to do a yield, you have to do another call, you have to do another yield, and you have to rename columns and stuff like that. And you can't make this part of expressions. That's why in Neo4j 3.1 actually the means of having user-defined functions was added. So you can have actually the same kind of code, but not exposed as a procedure, which is a more involved, kind of bigger thing, but just as a simple functions. So it almost looks like the same when you write it, and it looks much better when you use it, because you can just inline these 2 calls as a function call. So you create a UUID and you do the format directly in the expression, and you can use it in any kind of expression that you have. Either expressions that compute values in Boolean expressions, which are predicates, or anything else. You can use it everywhere where you can use an expression Cypher, which is in match, in return, in property assignment, in conditions, in with, and so on. So in APOC, we already had like 270 procedures, and actually it turned out that about 100 of them are actually functions, just not we were not just able to turn them into procedures. So what I did 2 weeks ago or so, I turned 75 of them into functions. So they are no longer procedures but functions, and so that means they get simpler in creating them and having the code there, but also simpler in using them. So you can now use a lot of things that you used to use in APOC as a procedure, as a function. And it's actually super easy to get started with this. So you don't even need to set up an IDE or a build environment or anything. So you can just use a JVM language called Groovy. And this is all the code that you have to write. Kind of just say, I want to use Neo4j Better 1. This is my user function. It looks like this. And then just compile this class to a class and then jar it up into Neo4j, restart the server, and it's available in Neo4j. So it's really easy to do.
Is this available in 3.0 or does it require 3.1?
It's 3.1. User-defined functions are only 3.1, exactly. So it's as easy as that, and so there's no excuse to not to try it out and play around with that. So what functions are also really cool for is if you have to encode something that's more of a complex business logic or so, that you don't want to repeat in query over query over query over query, but you just want to keep the code in one place, have it maintainable, have it tested, cleanly version in your development environment, and then in Cypher you just use this function as you would use a built-in function in the libraries. And then you can give them reasonable names, provide correct parameters, and so on. So you have something that's nicely encapsulated, and someone who just uses Neo4j in your application project can just call this user-defined function, for instance, to compute an interest rate, to compute a risk score, for instance, or something like that. And you don't have to repeat all this code time and again, and you don't have to do client round trips just to do that, right? Otherwise, you have to pull the data from the graph database, compute in the client, and then write it back, for instance, which is also not so nice. Something that's nice in 3.1 as well is that the at-description annotation moved from APOC into the product. So whenever you have a procedure, you can now have a descriptive text on each function procedure, and when you call TBMs Functions or TBMs procedures, then the descriptive head text is also listed there. So it's easier for users to figure out what does the function do or what does the procedure do. Something else that's really nice is default arguments. So what you can do is to leave off arguments to a function or procedure from right to left. So because oftentimes you have something like a general function which can be customized with additional parameters. But if you don't want to specify these parameters, then it just uses the defaults that are given like this. So many programming languages have this as well, so it's kind of nice. And so when you look at the kind of distribution of functions that we have in APOC now, is we have 3 left in date and time conversion. It used to be like 12, because you have to accommodate for all the combination of parameters, which you don't have to do anymore. So there's one format function, one parse function, and one to deconstruct the time value. Number conversion is the same, reduced also from 12 to 3. General type conversions, you can turn stuff from something into a map, from something into a node, from something into a boolean, which is really handy. Type information, as Neo4j is a schemaless database, it doesn't know so much about its kind of types, but there are meta things like APOC meta type, which gives you like, this is a node, this is an int, this is a boolean, this is a float, this is a map, and so on, which is sometimes handy to know, especially if you import data or if you deal with data that you don't know where it comes from or what kind of shape it is. Collection functions are actually the biggest part of this, because there's quite a lot of cool stuff that you can do with collections, which is not built into Cypher yet. I'll show some demos of that, but for instance, creating maps from lists, merging maps, stuff like that, or zipping two lists into pairs to compare values, for instance, later on, and so on. So there's a lot of stuff that you can do there. JSON conversion, so you can now convert from and to JSON. So for instance, if you have a more complex document that you also want to store in the graph, and you just get it in as a nested document, you can store it, convert it to JSON, set it on a property, and be done. And also, when you read data from Neo4j, you can kind of on the fly deconstruct stuff into from JSON into Cypher structures. For instance, check for a value in the JSON and then filter on that, for instance, or extract it as well. There are some text functions, for instance, joining text, triangular expression, replace, stuff like that is in there as well. And some hash functions, which you, for instance, can use to quickly compare two graphs if they're equal or not. So by just turning them into a text representation and then comparing the hashes of these text representations. That's it for the overview, and the next one thing that I want to show you is a demo. So you can, let me make this a bit bigger. Can you read it, everyone? Okay, cool. So there's a new procedure in Neo4j 3.1, which is called TBMs Functions. If you call this, then you get a number of functions returned. So Neo4j itself does not come with any built-in functions, but APOC now brings, as you can see, 71 here, functions, and you see the function name, the signature, and the description that I mentioned before is also in here. And then we can run some of them. For instance, we can call date format on this, so we get a millisecond timestamp and convert it into a string. We can also say, okay, I don't want to leave off the default arguments and say this is milliseconds, and I actually want to turn this into a date representation. You can do stuff like this now, which is really handy to deal with dates. And also the other way around, you can also do parsing, of course. Something else that you can do is, let's see, you can call any of these collection functions. So for instance, I have two lists coming from certain sources, for instance, from an import file or something like that. I have one list with keys, one list with values. I want to create a map from that. So I can quickly do this as well, kind of bring these lists together into a map. I can also take two maps and merge them, which is also very handy, especially if you aggregate information like, for instance, scores in a recommendation engine, and you kind of want to aggregate this and don't create new maps all the time, then this function helps you to merge maps, bring them together, and it's also just a function. And the same goes for other things that you can do with collections. For instance, I can do on collections. I have a range of 1 to 10,000 or something like that, and then I just say contains, and then I say I want to see if 200 is in this range, and it returns true, and stuff like that, which is really a fast implementation of an in-check, and so on. And you can also stuff like sort. So for instance, if I have a collection of random values or something. I'm not so good at randomizing. Let's range 1 to 100, and we want to have random. So here we have a random range, and then it gets it and sorts it like this, right? So I mean, I don't know if you've seen the collection stuff in but I can easily map and create corrections. So this is a random list of numbers. Yeah.
Do you also write your own sorting algorithm with this?
I have not yet. So sorting algorithms is an interesting bit because you want to pass in like a comparator. And so what I want to do in the future in APOC is that you can pass in like cipher snippets, and especially with the compiled runtime in Neo.js 3.2 hopefully, or 3.1 also has shown already compiled runtime. You can actually execute these snippets as compiled runtime, so bytecode compiled JVM code. So they should be really fast as well. So you could pass in a comparator, or for instance, in the graph algorithm, you can pass in a weight compute functions or stuff like that. So that's on a plan for this. And the last thing that I want to show is the JSON stuff. So I can just say, take a map, for instance, and this is a nested document, 1 to 3 or so. And I can convert it to JSON. So this is actually a JSON string if you look at it. And what I can do now is also do it the other way around. So if I have, for instance, here a JSON list as a string, for instance, coming in from an external source, I can say from JSON or from a property as well. So I can do from JSON list and then turns it into my cipher structure. That I then can do, for instance, I want to get element 0 and then key number A, and then I get the nested value out of it. And that's it with a quick demo. If you have more questions, or if you want to talk about what kind of other functions we should add to APOC, or you would like to see, or you would like to write yourself, please come to the APOC booth and we'll be there. Yeah?
So are these functions compatible with the with clause? So you can say like
yes.
this function has their...
Yes, so that's a good point. For instance, I can do, so actually with and return are almost equivalent, except for that one you have to alias in with. So for instance, I can do return value, comma value dot 0, comma value dot 0 dot A, and so I can, because function can be used anywhere where you can use an expression, and an expression is everywhere. So with is only composed out of expressions, the same as where predicates, for instance, you can also use functions there and so on. So everywhere you can use a built-in function like, I don't know, sine or toint or whatever, you can also use user-defined functions. So that's really nice because their applicability is not limited to anything. Something that I forgot to mention is that user-defined functions are read-only only, so you can't modify the graph in a function. So you have to use a procedure for that. So that's one distinction that's important to remember. Because they're for computation, not so much for updating things.
Can you return like virtual nodes?
Yes, you could. I actually didn't convert virtual node into a function yet. It would be an interesting discussion to have. Because virtual node can also create a stream of nodes, but in general it's possible actually. Cool, that's it. Thank you.
Thank you very much.